So let's now have a look at the inlet gate and gates in general. So we've got our run of the river power station again. I'll come around, and if we can zoom in just a little bit more, I'll be able to show you the gate. Now gates are used to start, stop and regulate flow. So very similar in a way to valves. We can see that this gate has a long spindle, and if we zoom in, we might even be able to see the hand wheel that is used to open and close the gate. Now this type of gate is quite small, and that's why you can manually actuate it. Generally, gates are going to be mechanically actuated, that is to say by hand, electrically actuated using a 3-phase motor normally, or perhaps a single-phase motor, relying on DC power in an emergency, or hydraulically actuated, and we'll use hydraulic oil pressure and a hydraulic cylinder to lower and raise the gate. Normal operation, you can use things like AC motors and also hydraulic pistons and stuff like that. In an emergency, you are going to either open and close the gates manually, which is quite difficult if you have a very large gate, or perhaps you'll use power from batteries and send it through an inverter to power the AC motors. And maybe even in some cases, you'll have an emergency generator, which will be hooked up to the control system for the gate in order that you can operate all the machinery required in order to open and close the gate. The reason that you have a normal operation and an emergency operation of all of the gates is simply that the gates are very, very important. If you cannot close this gate in an emergency, all of the water that is above the plant is going to be allowed to flow down to the turbines. If we look on the other side, there is the pipe coming down to the power station. This is known as a penstock. And the only gate between the inlet and the powerhouse is the one at the top. There is, however, additional valves further down. We can see we have a ball valve. We zoom in. And this ball valve is used to start, stop and regulate flow as well. Ball valves typically are not used to regulate flow. They're actually just on and off valves. The reason being is when you open a ball valve halfway, you have a lot of turbulent flow, and the degree to which you open the valve is not proportional to the amount of flow through the valve. So this is very much an open and close type valve. We can see also that this is hydraulically actuated. It's not going to be pneumatically actuated because the valve is too big. That cylinder is too small to use compressed air. It will actually use hydraulic fluid. But all of these items are installed to stop, start and regulate flow in order that we can control what is happening in the process. If we go further down, we should actually see another gate on the outside. We can see there it's mechanically actuated, and that will just close off the draft tube or the outlet of the powerhouse. So very, very, very important. You don't just want to close these off in an emergency, you'll also need to close them off to perform maintenance. When you're performing maintenance on the turbines, you close off the valves on the inlet and outlet sides of the turbine, and you close off the gates as well. You can then dewater, and that means to pump the water out of those spaces. Let me just zoom in for a moment. We can see the bottom of the turbine is along this pipe here. So if we closed off the gate and we closed off the ball valve that we saw earlier and maybe the other gate at the top, then we could pump the water out of this space, and then we'd be able to inspect our turbine, which we are looking at here. This is a vertically orientated turbine, and we're actually looking at an item called the runner. And when we pump it out and dewater it, that is the time to inspect all of these areas. If the gates or the valves are leaking, then you'll need to fix those leaks in order that you can work in the area safely. A little bit of leakage is okay, but obviously you need to be able to work in that area to perform maintenance. And it's never a good feeling if you're working in there and the space is gradually flooding. So that's the reason we have gates and valves on all of the water conductors. The water conductors themselves are any items that bring water to the plant or away from the plant. In the example here, we've actually got a penstock, that is this pipe, and we've got a draft tube, which is the outlet side of the powerhouse. Zoom in here. This item here would be our draft tube. So all of those things are called water conductors. Let's now